Welcome to the Fizzix 2 How-To series. This is video number 4, where we're going to discuss containers, measurement sequences, and animations. So in this video, we're going to introduce containers. We're going to introduce the front panel controls, which work under the interface I controls. We're going to show how to make a sequence of measurements. We're going to show simple animations using the iTick interface. We're going to show the experiment listing document, which is a document that's going to be published along with the software that shows all of the experiments. We're going to demonstrate the version numbers updates and the reason why we have kind of a weird version number system. And then finally, we're going to do a little overview of the vortex vector operators, because in the library that you're going to get with Fizzix 2, you're going to get the full vortex vector operators or library with it. So you can play with those separately if you like. We'll talk more about that in a moment. So again, for those people that don't know what Fizzix 2 is a simulation tool that uses new electromagnetism V5 to compute forces and or voltages between wires, magnets, and charges. This is an example of an experiment that was actually done, and this is the simulated version of it. Well, a little bit different, but in other words, all of these were experimentally verified. Okay, now we're going to discuss containers. I'm going to go off to that demonstration now. One of the things that becomes self-evident when using Fizzix 2 is that every time for every experiment we make a new menu item for the particular experiment that we want to simulate. And the problem is that we have all this stuff that gets globbed into the main form, and this can go on. Some of these experiments are very complicated. The one we're showing is very simple, and you can see all of the stuff we had to do just to set up a simple loop and a magnet and take a simple measurement. So what I devised is a thing called a container where we can offload all of this stuff from the main form. So let's create a container for our loop and magnet experiment. And the way you make a container is you create a new class. Oh, I gotta stop this. Create a new class. Now, typically when I create a container containing experiments, I use the prefix experiments. For this one, I'm just going to use the term example. So this will be the only container class that's in a file that's listed as example. And this is the example of the loop and magnet experiment. We're going to add that. Then all you have to do is derive this from F2 container. Okay, I guess I got 2 using FCX2. There we go. So now, by inheriting this, you inherit the ability for this container. All this container is now, instead of adding your objects to the universe, you just add them to this container. And then when you do your experiment, then you add this container to the universe. So there's going to be one extra step. So let's now go back to our form. And let's cut out all of our stuff. I mean, we're going to keep this. Okay, we don't have to clear anything. And there we are. So the first thing we do is we now have all these variables are now available as the public in the experiment. Now, to make sure they're public, we're going to put our cursor there. We're going to hold down the Alt key. We're going to drag down. all the way to the loop. And we're going to type in public to make all of these items public so they can be seen outside the class. So that we can change, these are now going to be our construction parameters. So instead of only one click handler being able to run this experiment, now we can run this experiment for multiple click handlers, and each one of them can change one or more of the default parameters. And I guess I got to be using standard. Okay, I guess using math. There we go. Next, we want to make a handler public void create d loop. Now we're creating our d loop, but instead of adding it to the universe, we're just going to say add. That's going to add it to this form. And we want to make this frame. Oh, I guess that's part of the magnet, but we'll put this up here anyway. Okay, we can start these off with like this. And make these null. Now for these, I'm expecting you're understanding what I'm doing from a C# perspective. All right, and then we want to do the magnet, public void create pdx. What are we doing? A 4? This is a 4. For single, or I guess that would be no for no second magnet. Okay, we put the magnet out here so we can grab it as well. I guess we have to make the frame before the magnet. Okay, so we make the frame with a particular rotation, offset, construction. We add the magnet. Let's start the offset to 0 for now. Matter of fact, let's make this the part that we send in. W. Degrees. And let's do that. So each time we build it, we can build the magnet at a different offset. And then here, if we want the measurement plane, we can make this optional. the heck? Obsessive clicking disorder I have. Okay, next we want to take a measurement. And let's return the Vim. Public F2 Vim measure. Return results. And we want to send the F2 universe in. No, we don't need to do that. We could do that. We just have to make sure we do these ourselves. Return results. Okay. Just put these here. Remember, we have to do these in the... So now what you have is you have a container called example loop, and that should be public so we can get it. So what we're going to do now is we're going to show how to do this here, and we're going to do loop and magnet container example. So all we have to do is say F2. I'll just get a copy of this guy, Control C. We do our clear all. Make a copy of our container. At this point, you would override any of the parameters. That you wish. And then you go x dot add d loop, or create the d loop. X dot create the magnet configuration. Do I have parameters for this? Oh, let's put 0 degree offset. Okay, then what we do is we say my universe dot add. And we add the whole container to the universe. And then we do these guys. Do those guys, and then we say F2 Vim dot results equal x dot measure, and then we put it to the however we want to put it out, tb output dot text equal results plus. See if we didn't make a mistake. Ha, did the whole thing without a mistake. Then we go example, container example. Oh, okay. We did make a mistake. don't have the magnet current. Oh, we forgot to make the magnet. Okay. M equal new magnet disk. I hope we don't have that someplace else and I missed it. All right, let's start over. I think that's it. So example, container example. And we got another one, unhandled object. Okay, I made a mistake in the measurement plane here. I didn't add the measurement planes, but I want to measure the loop. That's the other mistake. Let's see now. Should we do it again? 3 times the charm. There we go. And see, we got a very small measurement. So what we're going to do this time is we could change this. We could do it off 5 degrees. So we get a little bit more energy. There we go, a little bit more energy. And we can see what we have here is the same thing. And see it's off by 5 degrees. Because if we're right on the line, it's right in the balance between going from positive to negative. Okay, so that ends the container example. Next, we're going to discuss the front panel controls. So on the face of the Fizzix 2 software, there's checkbox A, B, C, D, and then there's text box E, F, and G. And those go by the name checkbox A, checkbox B, checkbox C, checkbox D, text box E, text box F, text box G. And these controls can be used in 2 different ways. One, to directly control experimental builds, and we'll show you that in a second, or to control animations, and we'll show you that in the next section. And in the experiments.pdf, which will accompany the software, there's more of a discussion on those. Let's go off to the demonstration of direct control of the build now. Okay, in this example, we're going to expand upon our container example to use the front panel controls so that we can get more than one experiment out of this container. So what we're going to do is we're going to make the third field here be the angle offset that we want to measure the magnet at. And A here is going to be used whether or not to turn the measurement plane on or off. So that's what we're going to do now. So we're going to stop this. And this is A, B, C, D, E, F, G. Let's start this off. Well, let's stop. So what we're going to do in here is we're just going to get a double angle. Okay, now in case somebody decides not to populate the field, we're going to default the angle to 0. And then we're going to put a try, because in case somebody doesn't. We're going to put a try catch, just to catch anything. And then we're going to say angle is equal to system.convert .to double. And we're going to use text box G .text. Okay, and then what we're going to do so that everybody knows what we got, we're going to say TV output dot text equals for angle equal angle. Okay, and then we're going to use this angle in here. Okay, next, if checkbox A dot checked and we're going to say X add measurement plane. And that's it. We're just reading the controls here. We're exercising the controls that we put into the container, and you can put all kinds of stuff in there. Okay, if you want an example of very extensive use of the front panel controls, you can look at the experiments.pdx. Okay, we're not done yet, because what we're going to do here is we have to make this a plus equal so we don't overwrite the previous stuff and put it on a new line. And then if, better yet, let's do this. Bool using measure plane equal CBA.check. So it makes it a little bit more readable. Okay. So if using, we go here. That way there you can change it to another control by placing it, by changing it in one place. Down here, if using measurement plane, then we have to say, oh, we should do the X measure, and we have to add an X measure to that too. String, let's return the whole report. String measure plane. Then I just say my plane get report. Okay. Then we say TB output dot text. Now you can dump this to a file. I'm just doing this because it's easy. My plane X dot my plane dot get report. All right, let's run this bad boy. Let's open up the viewer, hit F2, and we do example, container example. Wait for it, takes a second for the plane. Oh, I forgot to put the plane in there. Okay, so we want an angle, the angle 0, says put an angle of 15 degrees. And let's enable the report and run it again. What? Yeah. Okay, what I forgot to do is I forgot to make the measurement here. Forgot to do that. Can't display a measurement until you make the measurement. Start again. So let's put this at 15 degrees. We want to take the measurement. Let's open up the viewer again, hit F2 to get into a nice viewing position. And let's try this again. There we are, but why isn't the plane showing up? Oh, okay, I just had to refresh the viewer. So I did the measurement after, yeah. Okay, so to make this work without me having to refresh the viewer, make sure the last thing you do here is refresh the viewer. Let's do that. That should work right now. F2. We want this. We want 50. Let's make it 20 degrees. There we go. Because the measurement that's made here goes out and populates the field, but until you refresh the viewer, it doesn't get to the display screen. So that's the issue. What I did before is I resized it. Whenever you resize it, you cause the viewer to be refreshed. So that's what I did before. Okay, so that's a simple example of how you use the front panel controls to conduct or change, to alter, to control how experiments are built. Next, we're going to show a simple animation. In this example, we're going to show how to do simple animations using the iTick interface. What we're going to do is we're going to reuse the container we just made. We're going to add a new simple animation using the iTick interface. Okay, so I'm going to double click on that. And what we're going to do is we're going to basically copy all of this. We're going to throw most of it away. But you can see how we're reusing the container over and over again. Okay, and we're going to put there the start angle. We don't care about the front angle, the front interface controls. We're going to create the D loop. We're going to create the thing at 0 degrees. We're going to add X to the universe. And then on construction change, on local change, I'm not going to do any measurements. Okay, so what we're going to do, let me show you a new interface. We're going to go to the container. Okay, any object that is added to the universe can be constructed to take the iTick interface. And all you have to do is in your class hierarchy, put iTick. Now you notice it comes up red. So you go over here, the little bulb, and you say implement interface. Just implement it. Don't worry about doing it explicitly. Okay, we can get rid of this old stuff here. So don't worry about overriding the clone right now. I don't think we need that. There should already be a clone here. Yeah, we may not have to do the clone. We'll see. If it throws, we know. So all you have to do with the tick, what you're going to get from the system, you're going to get a tick time. It's usually every 100 milliseconds, depending on what you set the tick timer to on the main form. Okay, and this will be the aggregate time. So all we're going to do here is we're going to take our frame. Remember, our frame is the W, and the W is what we put the magnet into. What we want to do is we want to see the magnet going around and around and around and around. Okay, we already have the omega, and all we're going to do is every tick, we're just going to take the omega, multiply it by the tick time, and add it to the theta. So that's all we're going to do here. We're going to say W dot theta plus equal W dot omega, which is your angular velocity, times your delta time. That's it. And all you have to do is if you change a construction variable, you have to call on construction change W dot on construction change whatever. But this, what we're changing now, is a local variable, so we're going to return true to let the system know that we did change something. If we don't change anything, we return false. If we do change something, we return true. Let's see if this actually works. Oh, the other thing we have to do in our form is we have to make sure we say timer 1 dot enabled equal true. Let's see if this works. Hit F2. Oh, okay. So I have the thing set to 4 turns per second, which is kind of fast for the display. So what we're going to do here instead is we're going to just say, oh, let's just pick, radians per second dot from turns per second 0.1 turns per second. Make it a little faster. Let's do it that way. There you go. Okay, that essentially shows you how to do simple animation using the tick interface. In this example, I'm going to show how the front panel controls can be used to alter an ongoing animation. So if we go to, and let me demonstrate first, and I'll show you how it's done. So we go to the classical magnetic loop, and we take this guy here. We go to F2. I'm sorry, F2. Let me back out a bit. So watch this. So if I turn on C, it rotates. If I turn on A, I can stop the rings from rotating with the spheres. If I want to turn on the little segments between the spheres, I can do that. And if I want to paint in the special frame color wheel, I can do that. So you see how the animation is responsive to the front panel controls in real time. So how is this done? Let me show you. If we look at the front panel controls, let's just take A, properties, and we have a handler here which says if check change, on control change. All of these are responsive to on control change. For the text box, they respond to if text changed, they call on control change. So you can add other controls into this if you like. You can put number up down boxes, whatever you want. You just have to find a event that is appropriate and then call the on control changed. Now we look at the on control changed. All it does, because the control that calls on control change sends itself as a generic object. So all we do is make sure that there's a universe, and then we call my universe control sender, which will send to every object in the universe that has an I control interface will get this object. And what they're supposed to do, if they change something, they're supposed to return true to say something was changed, and then this guy will call on local change and refresh all the viewers to make sure the animation occurs. So let me show you what happens in this experiment that responds to that control change. And that is in the experiment classic flux animation. And you see that it's a container, and it has an interface for I controls. So it's going to get that call whenever any one of the controls changes. And then all you have to do down here is say, is the object a checkbox? And then if it's a B or a C or a D, it'll do the appropriate things. Now, if you change a construction parameter, you have to call the onConstructionChange yourself. And then you're going to return a true, and then the calling, the main outside universe calling, will take care of the local change and the viewer update. Okay, for example, here, this guy does not do any of this. Auto changing the rotation mode does not commensurate with a construction change. It's just a whether or not we're going to animate or not change. So that's not a construction parameter. So we don't have to call on construction change. That ends this demonstration. In this example, we're going to demonstrate how to take a sequence of measurements. And we're going to use our iContainer derived loop and magnet experiment to do that. Again, you can see the value here of the container because I'm reusing the same experiment over and over in different ways without having to repeat all of that logic and code. So what we're going to do is we're going to go back to our form, and we're going to add a last example of, well, I'll just say sequence of measurements. Sequence, loop, and magnet. Okay, so we're just going to take this guy here. We'll take the original guy. Is this loop and container now? Take this guy. Now what we're going to do instead is we're going to use this field here for how many measurements we're going to take. Now typically our stepper motor has 200 steps in a full turn of the circle. We're just going to do 50 of them because that's the default for this field. And that is field, I forgot what the field was. That's EF, field F. So we're going to do int n equals system.convert .to int 32 text box F. Okay, our start angle is always going to be 0. We're not going to use a measurement plane. Okay, double is going to be our delta angle. It's going to equal, so math.pi times 2, that's a full circle, divided by 200 is what our stepper motors have, and that is going to be our delta. And why is that giving? Oh, because it's not used yet. Okay. So we're going to create our loop. We're going to create our experiment. We're going to start at 0. We're going to add to the universe. Okay. Then all we're going to do here is for int I equals 0 while I is less than n, those are our measurements, I plus plus, okay, and our angle is going to equal I times our delta angle. Then we're going to go x dot w, because that's the frame the magnet's in. Theta is going to equal our angle. Now, because that is only a local variable, I only have to do my universe dot on local change. And then I can take a measurement and then say TB output plus equal and I'm going to say I, which is our measurement, plus equals results. And then we want to make the refresh viewers because we want to watch it happen. And then at the very end here, we want to basically say that we're complete so that the operator knows that the experiment has finished. Experiment complete. All right, and that should be all there is to that. Let's see if I can get this one right on the first shot out of the barn. So we're going to do... Now, our text here isn't going to update until the experiment's finished anyway. Let's go to F2 for a nice location. Example. Oh, of course. Oh, yeah. I got to do dot text. I want the text, not the control. Okay, for these sequences, make sure you open the viewer first and set it up, because once it starts the control, because I'm doing this in the drawing thread. Later on my to-do list is to move all the processing to a worker thread so that the interface isn't all clumped up, but that's a low priority item right now. Okay, you can see each measurement, each tick is occurring. And 50 points is 1/4 of the way around the circle. And you can have the software dump the graphic as it goes so you can make an animation out of it. I'll show you that in a moment. Hello. Oh, I think I just added it to the bottom. Okay, that's what I did. Okay, so there's all the sequence of measurements and experiment complete at the bottom. And you can see that at index 0, we have virtually no energy. And the maximum energy point, I think, is index 9, which is, or index 7 or 8, one of the, oh no, index 6, 5, 4, index 4. Looks like the maximum index of energy. Anyway, let's make sure we, before this starts, is we clear out the TB output dot text equal, just to make sure it's empty. I'm not going to run it again. This ends. Oh, let me show you how you can dump the image. I'm not going to do it for you. I'm just going to show you where you can find out how to do that. If you go to View, Solution Explorers, and you look for Experiment, PDX, down here where it says Take Measurement, it's all the way near the bottom. Simulate and record data. And there's the working directory comes out of this. All you have to do is grab all the viewport. What I do in here is I grab all the viewport observers. Okay, that's what the thing you open is called, a viewport observer. And then I do client capture area, and then I write it out to the directory. So all you have to do is copy this code. Now just be careful when you run this sequence and you want to capture images as you go. Make sure nothing is sitting in front. Okay, what I mean by that is if you have this and then you have something like this, well, every time you capture the client area, whatever in front of it's going to be recorded as well. I don't have a means yet to go in and get just the graphic that's there. The only way I know how to do right now is by client area. If somebody knows a better way to do it, please let me know. That ends this demonstration. Now we're going to discuss the version numbers, the slight changes to the version numbers. And why did we get all these weird version numbers? Well, the Fizzix software build that I use has all of the files loaded together in under one Fizzix 2 project. That includes all the animation files, all the experiment containers, the Fizzix 2 objects, the interactions, the Draw3D library, which is a wrapper around the SlimDX library, and the math libraries for Vortex and Vector. And what I decided to do in order that I could allow you to mess with these all you want, but I don't want these to be messed with, and then to be able to later on issue corrections and updates where we complete the interactions, add more F2 objects, or we're adding updates to the Vortex library. I wanted all these to be in their own separate library that's separate from the GUI interface. Therefore, the version number of these two elements here, we're calling this now the Fizzix 2 GUI, and that's got this version number. The library for the Fizzix 2 objects and the interactions, that's the FZX version 2.02. The SlimDX wrapper called Draw3D, which is Draw3D, is version 2.06. The math library for the vectors is version 1.01, and the Vortex library is going to be 1.04. 1.04 is coming out a little later. You're going to get 1.03 with the release, but eventually I'm going to release a new Fizzix D2 DLL, which is going to contain all of this. And the reason why I'm buckling all these up into a library is so I can improve the components without interrupting what you're doing here, because with these you can mess with them all you want, change them, whatever. And this way here, without interfering with what you're doing, I can produce a updated version of the library with any fixes and new interactions and whatnot. So that is the reason for all of these various different little version numbers. At startup, the software will dump all of the found. It'll go search for all the component versions. Here's the GUI version. Here's the Fizzix library version. Here's the Draw3D wrapper on top of SlimDX. Here is the vector versions, and here is the Vortex algebra version. Now you'll notice all of these version numbers have a little D on the end of it. That means right now I'm showing you that they're compiled for debug. For the library that you're going to get, everything's going to be compiled for the release. And typically the release versions run much faster because they don't have all the debug stuff to go through. Now this D over here is not relative to debug or release. This is just display 3D, as in 3 dimensions. So this D will not change. This doesn't mean debug here. So because we're releasing with the Fizzix 2 DLL, we're releasing the vector and the Vortex libraries and allow you to play with them at your will. We need to tell you what the operators do. Okay, so for multiply, for Vortex multiply, you use a regular star, where for vectors, star means dot product. You can read the rest of this on your own. There's a lot of variants of these two, so we're going to be producing an abbreviated Vortex video series because Vortex version 1.04 is coming out and will be copyrighted, and then we'll have a abbreviated video series explaining what Vortex algebra is and what all the operators are. Let's discuss some ending notes. There's going to be other supplemental videos for Fizzix 2. And one of them is going to be in how to take other types of measurements. That would be inductance, resistance, and possibly capacitance. Capacitance requires an update. So don't know if we're going to get this in the Fizzix 2. This will probably be put off till Fizzix 3. Okay, right now you can do inductance and resistance, okay, but I have not released a new planar inductance technique. Once that's released, then we will do the video which will show all of them. But right now you can do these guys. If you know what you're doing, you can figure out how to do those by yourself. And again, this will be done sometime after Cosmology is done and after the possible updates to the library to do capacitance, if we decide to put capacitance into the Fizzix 2 rather than the Fizzix 3. Okay, later, we're going to have the Stern-Gerlach experiment video series where we'll demonstrate how the experiment is done with Fizzix 2, and there will be some amazing revelations. Again, this will be sometime after Cosmology. I want to get Cosmology out of the way, so after Cosmology, we come back to electromagnetism full-time. Well, it's much time outside of my job. All that time now would be devoted to new electromagnetism. The beginning of the Cosmology video series, I will explain why we're focusing on electromagnetism, but why we still need to do Cosmology. Also included with the release, there will be a PDF that explains all of the experiments built into the software. And let me give you a little update on what that looks like now. Okay, so it'll be in PDF form, but it's going to discuss all of the experiments that are available from the main menu. Okay, where you find each one and what the front panel controls do. Either they're not used, or like, for example, the Paradox 1 experiment that magnet rotates, and disk rotates. Okay, so it'll go over every experiment that's built in and where you find them, what is the container that supports them. Everything will be in here. This is our Patreon site. There, the Fizzix 2 software will be released on or before the 24th of November, 2024. The search term will be SW for software and FCX2 for Fizzix 2. This will be released to engineer, Patreon levels, and above. This is our main blog site. I'm still having trouble updating this. I'm hopefully we'll get this done by the 24th. This is the blog site. Great shout out to Sebastian for taking care of this. And again, if I get more time, get people to offload a lot of this other maintenance stuff, I can get more time to do this. I'm sorry about that, but I will get there. We will get there. This is the YouTube channel where we make all of our releases. The releases are typically on Thursday nights at 9 o'clock. Right now, the series for Fizzix 2 is being released every other week to make sure that the Patreon members get it earlier than everybody else. Thank you. No more voodoo physics.